everyone. Welcome to discussion 2 for CS61B. This is actually the first discussion. The discussion numbers are in line with the week numbers per the university. So that's why we're calling this one discussion 2. But today we are going to be covering Introduction to Java. Let me get laser pointer. Okay, great. Let's get through this. So first, some announcements. Not all of these are relevant when this video is going to come out, but Lab 1, Lab 2, and Homework 0 are due on Friday. All of these do not fall under our drop policy because they are too important. Lab 1 and Lab 2 specifically are setup labs, and you really can't do any of the other labs, homeworks, or projects without having those done. Homework 0 is about respectful collaboration and communication, which again is just super important, so we really want to make sure that everyone gets it done. Homework 1 is being released Tuesday at noon, and it's going to be due the Tuesday following that. Office hours starts this week. It starts entirely online. Per the school's announcement, the next week we are going to be going back in person. Rooms will be updated on the office hour calendar for that. All of the office hours will be in SOTA. Lastly, please complete the pre-semester survey if you haven't already, even if it's late. You might not get credit for it, but it does help us generally get a understanding of who's in the class and what we should do to better serve you as course staff. Before we get into anything, my name is Anjali. I am a senior double majoring in computer science and linguistics. I took 61B in spring 2019, and this is going to be my 6th time teaching 61B. I do research in natural language processing. If you're interested in that, feel free to send me an email and I'm always free to talk about it and how to get into research. You can find my email on the slide and also on the course website in the staff page. Let's do some content review. So first things first, the anatomy of a function. So I'm sure most of you coming into here have learned Python or some other programming language in the past. So Java is a little bit more complex in its syntax, but the fundamentals are the same. So just like other programming languages, we have comments. In Java, one way to do them is with this like slash star star and star slash. And this is the type of comment that you want to make when you're kind of labeling what the function does. There's another way to do comments, which you'll see on the next slide. That's just 2 slashes, and those are kind of inline comments. I believe our style checker actually doesn't like it when you do those comments because those comments are really for notes to yourself while you're programming. So in your final product, you want to avoid those kinds of comments in this class. Next, we have keywords. So keywords are kind of the basic building blocks of Java. In this specific example, you see private, static, for, and if. There's a couple more, there aren't too many, but these kind of basic elements we will be covering over the next few weeks as we kind of give you your intro to Java. And we'll kind of talk about what each of these does. But what you have to know is that you can't make variables that are called what any of these keywords are called because they are special words reserved for a purpose in Java. Next, we have type declarations. Now, Java, unlike Python and a lot of the newer programming languages, is statically typed. That means that whenever we create a variable in any place, we have to tell Java exactly what that variable holds. And this is important because in Java, you can kind of imagine that there is this place in memory where it has all the variables for your program, and Java wants to know exactly how big of a space it should leave for every variable that you create. So an integer, maybe that's 8 spaces, and there's another example here where maybe a character is only 4, and so it wants you to tell it exactly how much space it should reserve. Next, we have variable and function names. These allow us to refer to our stored values, and again, that's pretty similar to what you'll see in other programming languages. So we have this variable called limit here, print primes is a function name, again, p, and then is prime, variable and function name, and there's a whole bunch. You can make these up. These can be whatever you want as long as they're not a reserved keyword. And lastly, the biggest difference that people see immediately is that Java uses brackets and semicolons. So every single line has to end in a semicolon, and all of these clauses will need to be surrounded by brackets. So a clause in this context might mean the body of this for loop or of this if statement, the body of this method. All of the stuff has to be contained within brackets. It takes a little getting used to the first couple of weeks, but after a while, you'll be going back to Python and struggling to not add brackets everywhere. Now we can talk about classes. So again, another difference from Python. Python is interpreted. So that means that you can write a line of code and the computer will just do it. But Java is not interpreted. And what this means for you is that all code in Java has to be contained within a function, and all these functions have to be contained within classes. So here, an example is a CS61B student class. This first line is a class declaration, and it's just public. That's who can kind of use or see this class. The keyword class, and then the name CS61B student, which we just made up. Within this class, we have something called instance variables. So instances of a class are sort of like individual CS61B students. So maybe you're a student, your friend's a student, the other person in your discussion is a student. Each of you has a unique ID number, or not unique, but individual ID number and individual grade, right? You getting an A on an assignment does not change your friend's grade. So these variables belong to each instance individually. On the other hand, we have these things called static or class variables, and these belong to the class as a whole. And the example here is, let's say you have professor variable, and you, your friend, and that person in your discussion all share the same professor variable. If Professor Hillfinger were to take a trip for a few days and someone else were to come in and teach for him, the professor would change for everybody. And that's why we have these class variables. Next, the constructor. So the constructor is how you create an instance. And what you can do is you have any amount of parameters that you want to pass in. You can have nothing, you can have just ID, you can have ID and grade. You just have to write a constructor that takes in each of those different options for the parameters. And then you can assign those parameters to variables or just any random value to these variables. You want to assign a value for all of your instance variables in here. You don't have to. These instance variables will be auto-generated if you don't assign anything. Most types have like some default value. I think for numbers it's 0, for objects it's null, but we don't really want to do that just because it makes code hard to read. So assign something inside your constructor for all of your instance variables. You see this keyword. If you're familiar with Python, the this keyword is very similar to the self keyword, except we don't have to include it in our parameters because it's always hanging around. You don't have to include the this keyword. Unlike Python, if this wasn't here, this code would run exactly the same. But this keyword is useful if you have a variable in the instance level and a variable within the function that are named the same. You can use the this keyword to differentiate between them. Next, we have instance methods. So here is an example of an instance method. This method does something that belongs to the individual instance. So for example, if you watch lecture, that does not impact your friend at all, right? You watching lecture has no impact on anything to do with your friend. So watching lecture kind of belongs to you, your instance. On the other hand, we have class or static methods, and these are symbolized by the static keyword, just like the variables are. And these affect the entire CS61B student class. An example here, maybe updating grades, you know, maybe it sets the Hillfinger variable to something else for some reason. I don't know. Whatever it does it for the entire class. Static variable methods can only impact static variables. They don't have access to the individual instance variables of any instance. They only have access to the static variables. Instance methods can affect either instance variables or static variables, because they have access to everything within an instance of a class. If that's confusing, that's totally fine. This is something that takes getting used to, and you will have plenty of practice in the next few weeks before the first test. Okay, so you have class. Now, how do you use it? So here you see, first of all, that we have the same kind of class declaration going on, CS61B launcher this time. That's because, like I said, all code in Java needs to be held within some class, even the code that you run from the command line. And then the question becomes, how do you run code from the command line? Well, Java has this very special function called its main function. And so if I wanted to run code, I would just run Java CS61B launcher, and it would run this class's main function. This function signature is very specific. It has to be exactly this function signature. The public in this function signature means that this function can be accessed from outside of this specific file, which again is super important if we want to run it from the command line. Has to be public. Next, it has to be static because otherwise we would have to create an instance of this class before we could call it, but there's nowhere to create that instance from if we're running it from the command line. So it has to be static. It has to return nothing. This is important because it's return once this function is just done running, you're going to exit out of the program completely, and that return has nowhere to go. So you want to return void. Next, you want it to be called main. It has to be called main because this, again, the special function is what the computer is looking for when you tell it to run this class from the command line. So it's just a special word. It's just main is just special in that way. It has to be called main. And lastly, the arguments have to be a string array. I don't actually think it needs to be called args, but tradition says it's called args. And what the string array actually will contain are the command line arguments that you pass in. So let's say you do Java CS61B launcher .java, and then you can type in whatever word after it, and those will be passed in as the arguments. Now, this method doesn't actually make use of these arguments, but if you refer back to lecture from Monday, January 24th, Professor Hilfinger walks through an example where the arguments are used. Now, that is an important thing. You're going to see it a lot, so just make sure you understand it. Moving on, how do we instantiate a class? So the first step is creating this new variable. So we have student1, and we're telling the computer, okay, student1 contains a CS61B student. Great, that's all we're doing. We're creating our variable and telling the computer what this variable contains. Next, we're going to do something called instantiation, which is referencing back to our constructor. This new keyword is vital. This is what's telling the computer that we are in fact creating a instance. And then we do CS61B student, and then we pass in our parameter. If you recall, our constructor takes in a number, the ID number of the student. So we have to pass in something. We can't do nothing. And then we do an assignment. So we take what's created from this little clause right here, and we assign it to student1. So now student1 contains a CS61B student with the ID number 32259. You can also do both of those lines at the same time. Here we see student 2, it's a CS61B student. We're going to create a new CS61B student and assign it to student 2. Both of these are equally valid. You'll want to use them in slightly different situations, but it's really up to you for the most part when you want to split it up and when you don't want to split it up. Next, this is how you would call an instance method. Instance methods have to be called on instances, so you cannot call CS61B student.watch lecture because then the question would arise, which CS61B student is going to watch lecture? You're not sure. So it has to be called on an instance. Static methods, on the other hand, can be called either by the class as a whole, as in this example, or on a specific instance. So student1 dot update grades would be equally valid, and it would do the exact same thing because every instance has access to all of the static variables and methods. The class itself doesn't have access to the instance methods. Just to reiterate, static variables and functions belong to the whole class. Instance variables and functions belong to each individual instance. These slides can be found on the website if you'd like to review this material. But let's get to the worksheet. So the first problem is called Old Town Code. I know, so modern, so up to date. But the idea behind it is I want you to tell me what each line in this sort of script, I guess, does. In the actual worksheet, the Python code is given right below. So in case you aren't too familiar with Java yet, you can kind of reference that to see what it would look like in Python, but I encourage you to do this without doing that. But yeah, say what each line will do and give the final console output of this code. Okay, I'll give you guys a few seconds to do that and then we will reconvene. Okay, welcome back. Let's go through this. So the first line, it declares the variable x and assigns 7 to it. Very similar to the way that we created a class, you can just create this sort of more primitive type the same way. And then number 2 does the same thing with a string. You create the variable chorus, it's of string type, and then you assign a string to it. And then we do the same thing with queen. Queen is of type singer, and then we create a new instance of singer. You see that new keyword, and then you assign a singer to it. Next, we have this sort of while loop going on. So first, we check whether x is still greater than 0. So x starts off at 7. So the first time we check it, we're good to go. And then the first thing we do is we deduct 1 from x, so now it's 6. And then we call the queen.sing method on chorus. The queen.sing method returns something, but it doesn't print anything. And since that return isn't assigned to any variable, it basically just disappears into thin air. Regardless, this happens 7 times until x is equal to 0, at which point we exit the while loop and move on. Next, we are declaring a variable called phrases of type string array and assigning an array of strings to it. Now, there are a few ways that you can create an array. We will be going over that next week. This is just one of them. So if you've seen it done a different way, don't freak out. There are just a couple different ways to create arrays in Java. Next, we have this for loop. So this is something that you don't actually really have exactly in Python. You guys have something closer to what's a for each loop in Java. So this first clause right here, what it does is it creates a variable called I and sets it to 0. This is done the same way you would do it if you were just doing it like inline the way it's done up here, just down here. Next, what you're saying is, I want to keep looping until I is no longer less than 3. So this is the kind of loop condition, and it's again the same as what you have in this while loop up here. It's just put in the middle of this larger clause. And lastly, you have the incrementation. So the incrementation here is I plus equals 1, which means you're going to be incrementing I by 1 every step. And this is done after the body is executed. So what's going to happen is the very first time you enter, you're going to say I is equal to 0, and 0 is less than 3. So I'm going to print out 1 taught me, and then the 0th item in phrases, which is love. And then we're going to increment I by 1, and then go back and check again. And do that 2 more times, which will print out 1 taught me love, 1 taught me patience, 1 taught me pain, and at that point, I will be equal to 3, and we will no longer satisfy this condition of being less than 3. So then we'll move on 1 more time, and we will print out the last phrase in phrases down here, which is what does the fox say. Unlike Python, you cannot do negative indexing in Java, so you'll have to do phrases.length minus 1. The final output is 1 taught me love, 1 taught me patience, 1 taught me pain, and what does the fox say? Next, let's do another exercise in sort of reading code, but this one's a little bit more complicated. So there's kind of two questions here. The first is what does this return when the input array is specifically 30463 and k is 2? And what does this answer mean? Doing the first part will help you get the second part. I will give you guys a minute to think about it, and then we will reconvene and talk about it together. Okay, let's do this. Let's work on this together. So, the first line, we're just doing some setup. If you recall, public means that anyone can call this method, even people outside of our specific class. Static means it's not an instance. Int means we're returning an integer at the end. That part's important. Mystery 1 is just the name, and then we are passing in an input array of type int array, and we are passing in an integer called k. So I have this kind of set up with the given input and k as it's given, and let's go through it. So first we're going to set k to be equal to input array k. So k is 2. Arrays are again 0 index, so 0, 1, 2, that gives us 4. Next we have answer equal to k. That just means that k answer is going to be also 2. And then we have index is equal to k plus 1, which is 3. Now I get to the interesting part. So we're going to say while index is less than input array dot length, we're going to keep executing what's inside this block. So input array dot length is 5 because there's 5 elements, and index is 3. So what this is doing kind of more conceptually is that we are going to keep executing this until we run out of elements to execute it on. So we're on this third element, again, 0 index, that's this element over here. If input array index is less than x, then we will execute that block. So input array at this index is 6, x is only 4, so this is false. We're going to skip these lines and just go straight to incrementing index by 1. So now index is 4. This is still true, 4 is less than 5. So we're going to do input array of index is less than x, and this time 3 is in fact less than 4. So we are going to say x is now equal to what was at that input array index, which is 3, and answer is equal to that index where we found it, which is 4. We're going to increment index one more time, and this time this is going to evaluate as false because index is 5 and so is input array dot length. So now we're going to skip all of these lines and just go down to return the answer. That's going to return a 4. And what does this do conceptually? The returned value is the index of the smallest value in the array that occurs at or after index k. Okay, so let's see a use case for this. So in this case, we are going to be evaluating kind of what another function does. So here we have a function called mystery2. As you can see, it calls mystery1. So we're going to pass in the initial input array of 30463, and now the question is, what does this function do? Again, I recommend that you kind of run through it once with this input, and then from there figure out what it does. I'll give you a minute to try it out on your own, and then we can reconvene. Okay, let's talk about it. So first things first, let's do some setup. So we have our input array. I've pasted in the numbers from down here. So we have index equals 0, so that's set up. And now we have our while loop. So index is currently 0, the length is 5. So this is true, we can go inside. Oh, it looks like I have skipped that one. But yeah, we are going to set target index equal to mystery1 input array index. So as you can see, the smallest index is 0. So the smallest item in this input array is 0. The index at which it's at is 1. So we're going to put that in as target index. Now we have now we're actually doing line 5. And so here we have int temp equals input array at target index. So that is that 0. Now we are going to do input array at target index is going to be equal to input array at index. So input array at index is this number right here. It's 3. because index is 0. And we are setting input array target index to that. So we're going to replace the 0 that we had here with 3. And now we're going to replace the 3 that we had here with 0. So what did this entire block do? It swapped those two numbers. And now we're going to increment index by 1. Again, we're going to go back up here. Index is 1, less than 5, still true. And we are going to now set target index to mystery 1 input array index. So this time we're basically getting the smallest element, starting from this element and going that way. And that happens to be this 3 right here. So the swap effectively does nothing because it's swapping with itself. Increment index again. Again, still true. We're going to get the smallest element starting from here, going that way. So this time we get our target index is 4, 0, 1, 2, 3, 4. That makes sense. And so now we're going to swap that with this, with what's at index, which is this 4. Just like that. And now we're going to increment index one more time, do it, still evaluates to true. This time we're going to be looking at the 6 and the 4. The 4 is smaller, so target index is going to stay 4. And then we're going to update our temp to be the 4 itself. And then we're going to swap the 6 and the 4. Last time, updating index plus 1 while index is less than input array.length evaluates to true. And then we are going to set the target index to be equal to 6 because there's nothing smaller than 6 because there's no other elements left. And then we're going to swap the 6 with itself. And now this finally evaluates to false. So we're going to go down here. And this isn't going to return anything because this return type is void, unlike our previous function. So we're just done. What does this function do? This function sorts the array in increasing order in place. So our input array turns into 0, 3, 3, 4, 6. We'll learn more about sorts later, so at that point you will recognize this as selection sort. Okay, so let's talk about the Fibonacci problem. So this is just some recursion practice to get us back in that mindset. I'm sure 61A or whatever programming class you took before this already covered this stuff. We're just trying to get those gears moving again after break. So I want you to implement a function, fib1, that recursively calculates that nth Fibonacci number. And the hint here, if you don't already know, is that the Fibonacci sequence, the nth number is given by the n minus 1th number in the sequence plus the n minus 2th number in the sequence. So I'll give you a second to try it out and then we can go over it together. Okay, let's go over it. So first things first, with recursion, always base case. In this case, the base case can be written a few different ways, but the core idea is that the 0 and the 1 in the Fibonacci sequence are just given to you. There's no way to derive those. They just are the first two digits in the sequence, and that's just given to you from the beginning. So we're just going to write if n is less than or equal to 1, return n. Other options include if n is equal to 0, return 0, and if n is equal to 1, return 1, etc. N is never going to be a negative number because it's giving us the nth number in the sequence, which is inherently positive. And then we can talk about the recursive case. So I basically gave you the recursive formula up in the hint. And so all you have to do is plug that in, return fib n minus 1 plus fib n minus 2. Now, if you're looking at this, you could probably tell that this is not the most efficient way of calculating the Fibonacci sequence. You will be recalculating numbers a lot. So for the extra problem, we're going to try to make it a little bit better. So here we have the Fibonacci, another version of a function call for the Fibonacci sequence. So we have fib2, and we have 4 inputs. So the hint will really help here. If you want to compute the nth Fibonacci sequence, number in the sequence, we want to call fib2 n001. Sorry, there should be a comma there. There isn't. And I'll give you a chance to try it out and come up with a solution. This one's a little harder, and then we can talk about it. Okay, let's wrap this up. So again, like I said, first thing, core thing, we're going to want to figure out what these numbers mean, what these inputs mean. So here, I'll just list it out. So n is the number of recursions in the end. It's also the number of the Fibonacci sequence that we are trying to get, right? So that's pretty given because we're passing in n. K is the number of recursions we've already accomplished, or how far we are, which Fibonacci number we've already calculated. So the hint here is that it starts at 0, and we're going to be incrementing it every time we call on that. We do a recursive call. F0 and F1 are going to be the second to, or the last and the second to last Fibonacci numbers. Flip those, sorry. Or sorry, the second to last and last Fibonacci number. I had that right the first time. So the hint here is that it starts off as 0 and 1 respectively, and they're called F0 and F1. So we're going to start with those initial two. First, let's write the base case. So here we want to stop once k is equal to n, once we've calculated k Fibonacci numbers. So the number recursions goal has to be equal to the number recursions accomplished. The reason we return f0 is because when n is 0, we want it to return f0. So it's important that we're returning f0 generally. And then we have the recursive call. N stays the same because which Fibonacci number we're trying to calculate doesn't change this whole time. K increments by 1, like I said, as we calculate each Fibonacci number. F0 becomes F1, right? The second to last number becomes the last number, or what was previously the last number. And then F1 becomes the next Fibonacci number, which is just the sum. This should say F1 and F0, and I'm sorry that it doesn't, but you can imagine that it does. This slideshow is 80 slides long, so, there's going to be some small typos. I'll fix them. But yeah, F1 becomes F1 plus F0, which is the next Fibonacci number. And that's it. That's all you have to do here. I know this is kind of hard to come to, so don't worry if you didn't get it. You'll get a lot of practice in the next few weeks with Project 0 coming out and the homeworks and the labs and all that jazz. Anyway, that brings us to the end of today's discussion. I hope this all made sense. If you have any questions, feel free to ask on Piazza or come to office hours. And yeah, I'll see you guys all next week. Good luck with everything. Bye.